we said that cumulative incidence is different from incidence because the cumulative has to do with you are adding up. And then this morning we start with a prevalence measure. Now, if I may, I think somebody defined it yesterday. Now, I'm going to go back to that definition. Now, prevalence is the total number of both old and new cases. Old and new cases. So, and then we have point prevalence. Point prevalence. That is, you could be taking a cross-sectional study of the number of people that are infected with malaria just within a day. I mean, you can take that with questionnaire, just like somebody said yesterday. And then we have a period prevalence. You can take it over period of time. Okay, so we move to climatology. Now, climatology is a branch of atmospheric science that focuses on the study of climate over a period of time. And then we're defining climate as the long-term shift in temperature and weather patterns. And we discussed that there are artificial effects, there are natural effects. And when we talk about climatology, it's a separate science that has influence on public health and epidemiology, because we are seeing the effects all over the world today, globally. Now, the way climate has been handled by human through the burning of fossil fuels, coal, and gas. Now, climatologists study climate patterns of many periods of time, such as months, years, centuries in certain regions, and aim to predict changes and how the changes will affect the environment. So now in climatology, there is a mathematics of climate. That's mathematics of climate is called mathematical climatology. Now, where you are using some tools in maths to respond to questions in climate problems. So, and then we have the climate system. Now, from the space to the atmosphere to the ocean. And then you see there the net in the space, you have the net solar, the shortwave radiation, and then you have the net terrestrial long wave radiation. You have the atmosphere. In the atmosphere, you have the clouds, and then from the clouds, you have the precipitation, and then you have the air-ice interaction. So all of these features you are seeing depends on geography. Now, the geographical location depends on the kind of experience you are going to have in terms of the climate. So this may not, and even the environmental condition is determined by geography. So, and that is why you find out that, I mean, in Nigeria now, in the southern region, there are more rains. And then when you go to the north, the up north, there are less rain. So there are changes, different kind of changes and variation when it comes to the issues of climate and weather. Now, different processes, different scales, and different scales, that means both spatial and temporal. When I mean spatial, we mean location. When we mean temporal, we mean time. Now, you see the clouds, the precipitation. This has effects on the general body, the ecosystem. Now, we're talking about now disease, now infectious disease. Now, precipitation. We said when the rainfall, the precipitation is very, very, very high, what happened? Then you find out that beyond the normal threshold, a lot of the stagnant water, the patches where mosquitoes are laying their egg, they will be washed away. So mosquito abundance cannot survive. There cannot be multiplication of mosquitoes when there is high precipitation. And then when it is normal, you find out that, you know, people, I mean, there are stagnant water, there are places where mosquitoes are laying their eggs, and then the next thing is you begin to see mosquitoes spreading, and then malaria is also very high. Now, when there is flood, now mosquitoes during the flood, because there is high precipitation. Now, during the flood, the mosquitoes, stagnant water patches are washed away. But immediately after the flood, you will see patches of water around. And then after the flood, there will be mosquito abundance. So now we also see that when there is little precipitation, now, I mean, mosquitoes cannot really, the effect of the abundance of mosquitoes will be less. So there is a way precipitation affects malaria transmission, but it is not a direct way. Now, when you look at cholera, now when there is more rain, like flood, then you can expect cholera outbreak, because the water level will be affected, and then there will be mixture of all kinds of water from the sewage system and all of that. So people will begin to have diarrhea, and then, so all of those diseases, some of the diseases some of you are working on, they are having some relationship with rainfall, because when the rainfall is high and there is flood, you find out that there will be a lot of disease, diarrhea disease coming up, and then people are having cholera and diarrhea disease. Now we have the air-ocean interaction. Now, you find out that at the sea level, sometimes when you go to areas around the ocean, the temperature changes. The temperature changes. So it may not be the same on the land. So the life on the water and then the life on land, there is always a variation around that. And then we look at the volcano gases and particles. Yeah, like the volcano eruption. It's one of the effect of climate change. Now, when there is volcano eruption, like one that a very close one that happened in the Igbeti recently, there was a rock weathering, and then people were, they were running away, their houses were affected and all of that. So, and then, so these volcano gases also contribute to climate change, and the release is affecting the ozone layer, and you find out that there is intense heat in certain places. So in the recent time, certain places where the mosquito has reduced, not only, there are about 30 species of mosquitoes, Anopheles mosquitoes. Yes. So it's not only, what's it called, that there are mosquitoes that are not causing malaria, but they cause other things. They are intermediaries, yes. They pick other disease. So there are places that mosquitoes have been eradicated, but because of the climate change, they are coming back. Some of the diseases we are not seeing for several years, they are coming back to those locations, even outside Nigeria. So the issue now is that, I mean, there is a big challenge in terms of the climate change, and we need to respond to it. We must not say that, oh, we don't know what is going on. So I need to move. Now, weather versus climate. Weather is the state of the atmosphere at a given time and place with regard to temperature, air pressure, wind, humidity, cloudiness, and precipitation. So the term weather is restricted to conditions over a short period of time. Now, there is a difference between weather and climate. So weather has to do with now. Like that's why we say, what's the weather forecast for today? So people want to know. Some people say there will be rain in certain places. There will be the weather will be, the temperature will be around 35 to 42 degrees centigrade. And then I'm not sure in Nigeria we are prepared for anything. People don't listen to such. But in countries where the weathers are very harsh, before you go out of the house, you have to know, because if you don't know, you can die. Yes, You can die that same day, you can die because, I mean, if the weather changes. I was somewhere some time ago, and then I went out with a shirt, normally, and a trouser because the weather was okay. And I had not moved more than 15, 30 minutes away. I was just walking on the road to go and get something. And then the weather changes. Oh my God. I ran because my bones were already feeling it. They were entering my bones. And your blood will just freeze. And that's all. You are gone. Or the leg is gone. There are people that have amputated their leg, but they didn't prepare. So in Nigeria, we don't prepare. Even if they tell you temperature, you don't know. What's temperature? Now, if the temperature is high, you are supposed to be drinking water. Do you know that everything is not demon? Some things that, is because of dehydration. Some people die. Just dehydration. You just and fall down. If he has had water with him, because the temperature is, the environment is harsh. The environment is dehydrating water from his body or our body, and he's taking water. From time to time, he has the bottle of water, filling it. You are going to be fine. So because you have understanding of the temperature around you. But in Nigeria, you just find somebody, while he's sweating like this, he's still in this, and then he's getting dehydrated. We don't care. So we should take note of all these things because there is a way they affect our health. So, and conditions average over long periods are referred to as climate. So that's a long-term shift. Long-term shift in temperature and in the condition of the atmosphere. Now, we have the time scale. Now, the climate variability here, which is, climate variabilities are temperature, rainfall, that's precipitation, humidity, and all of that. Now, you will see this can go on between 2 to 3 months. You can determine them, or 6 months to 1 year, or decades. Like decades in 10 years. So, climate variability can vary between 1 to 10 years. Can begin to vary. Temperature can, but the measure of climate change takes decades before you begin to see the change. Climate change takes decades. Now, several decades. Do you know when people have been talking about the issue of climate change? It's been long. In fact, some of us, since we were born, they have been talking about climate change, but nobody cares. So, climate change, several decades or centuries it takes before you start experiencing it. It's not something that is instantaneous. So it takes time. But for climate variability, it takes between 2 months to 10 years. You are seeing the variations. That's the beginning before you advance to climate change. So the issue of climate has to do with climate variability and then advancing to climate change. So, and then climate change means that the situation you are experiencing in this place has already changed completely. That's why you see now in Nigeria, people that were born, in maybe like 50 years ago, than, maybe, or 70 years ago, they will tell you that everything has changed. Go and listen to them. They tell you everything has changed. Some of them knows the time that rain is going to fall, and it will fall that time. They know the time that there will be dry season. Everybody knows. But when you ask them, say, no, everything has changed. And do you know that has had impact on our agriculture? It has had impact on our agricultural system. So people, the benefits we are supposed to be getting, and apart from that, because there is no advancement in knowledge, as those things are happening, are we collecting data to inform the farmers that, okay, this is when you can plant now? It's not the same way. So the farmer is still, some of them are still following the way their forefathers were doing it. So they were not getting the result. Some of them are complaining. They don't know the reason. They don't know why. So these are some of the challenge that, climate change. Oh, this thing is dancing. Oh. Now, climate variability. You have 2 to 3 months seasonal forecast. We're despite the seasonality. I mean, what's by now? You should know it offhand. What's seasonality? Eh? Patterns. Okay. Peak of infection, systematic peak of infection, or of anything, climate, or yeah. So at certain time of the year. Okay. So, like you have seasonal forecast within 2 to 3 months, and then you also have 6 months to 1 year seasonal forecast, like 6 months to 1 year seasonal forecast. You can have decades. That means decadal prediction. That means, yesterday we're talking about forecasting, prediction, and projection. There are 3 different things. Now, when you are forecasting, you are looking at, there is also what we call the nowcasting. Nowcasting is you want to know what will happen within the next 1 week. 1 week, 2 weeks, and then because you need to plan. We want to plan. The reason for forecasting is to plan. When you know what is going to happen, you plan against what you think that is going to happen from the forecast to beat against it. Now, the forecasting is showing this within 1 week, 2 weeks, then 1 month, 1 year, 2 years. That is forecasting within 2 years. Then when you talk about prediction, it's within 2 years and 10 years. 2 years and 10 years. And when you talk about projection, you are talking of 10 years and above. So you are projecting several decades and then centuries for projection. Now, this is climate knowledge for public health by Hippocrates, the father of medicine. Now he says, whoever wishes to, this was written in Greek, I'm sorry, and then wishes to pursue properly the science of medicine must proceed thus. First, he ought to consider what effect each season of the year can produce. All the seasons are not alike now, but differ widely both in themselves and at their transitions. The next point is the hot winds and the cold, especially those that are universal, but also those that are peculiar to each particular region. And he must also consider the properties of the water. Now, these are very important things that Nigeria, we don't take cognizance of. And underlying, basically on the foundation level, you find out that they are affecting a lot of things in our environment. Now, various seasons that we have, the rainy season, there are certain, that's why you see that in certain season, like the rainy season in Nigeria, there are certain crops that come out that season. There are certain fruits that come out that season. Those are the fruits that are meant for you to survive during that season. Now, when you come to dry season, there are certain fruits that come out during that season. Those are the fruits that are meant for you to survive, if you understand what it means. They are meant for you to survive during that season. Are you getting me now? So the thing is, like there are certain diseases also that comes out during certain season, and then there are nutrition that are available to combat against those diseases during that season, that are coming out during that season. So for each challenges, there are provision. If you understand the fruits that are coming out, the kind of thing we are getting, there are materials to combat against that challenge. Now, climate change and health. Climate change will affect in profoundly adverse ways some of the most fundamental determinants of health: food, air, water, pollution. I have somebody here who is working on water pollution. Now, the effect of climate has affected the life below the water. So some of the time, a large number of them are dying. Now, if you go to some places where they are, I mean, let's say in Port Harcourt, like Bayelsa, Port Harcourt, where they are drilling oil, most of their water are already polluted. So even the life under the below, they are already infected. If you eat those kind of fishes, they are having some chemicals in their body that can affect your system. That's why people are having cancer and all these terrible diseases. Yes. So you find out that even the food people eat has affected. There's shortage of food because there is no correct plan. The pollution. Now you should thank God for this place. This kind of the air. This is a very quality air you have been breathing for the past 2 days. If you are going to pay, that's billions of naira. We are going to charge you. Quality. Go to Lagos. That's when you know the difference. You know the difference when you go to. Once some of us get to Lagos, this has changed, though. You know the air quality is no longer there. And then people are dying gradually. You see, some of these things we are talking about, they are long-term things. They are chronic. It's not something that will just happen one day. No. The thing is going down. The lung is being affected. It could take 30, 40, 50 years. There is degradation. Until one day say, we don't know, they use different drugs. It will not work. So sometimes some of you in Lagos, you better come to this kind of place once in a while to come and take care. And when you are going back, you put some inside the bottle. It's not moving, no. Okay, it's moving now. Okay. Okay. So the time scale, I think I've discussed this. Space scale, climate, and health. So you find yeah, that's when you talk about space scale, you are talking about different geographical location. Now that's why, like I said, as close as Kogi is to this place, you cannot say that the dynamics of, I don't know in Kogi at least, but everywhere has malaria. But there are some diseases that are also here, like infectious diseases that are thriving in this kind of state. Every state has one particular, apart from malaria. Malaria is a general thing. You understand? So let's even talk about malaria. The dynamics of malaria in Benue State, until we check, may be different from that of Kogi State. Now the reason, there are many reasons for that. Now we have to check what are the population, what kind of work do they do, the kind of food they eat, and a lot of factors in terms of even environmental factors, that can affect disease thriving. So all of those things has to be put in place, and that is why you see now, if you are conducting experiment in Nigeria, you may not get the same result if you take it abroad, because the weather is not the same. So the same result you are get in Nigeria, if you get there, everything will change. So because all of this, so when we talk about space, in terms of location, there are so many factors that influence, because the population, the demographic factors, the climatic factors, the environmental factors, the like land use and all of that, they are important factors to put in place when it comes to spatial influence on certain diseases. Now, what is climate risk management? Climate risk management is a generic term to refer to an approach to climate sensitive decision making that is increasingly seen as the way forward in dealing with climate variability and climate change. The approach seeks to promote sustainable development by reducing the vulnerability associated with climate risk. Now, do you know that, when you see that countries like Canada, they are giving you, um, they give you paper so that you can come immigration, migrants. Some of you are wanting to apply. Some of us here have also applied to go to Canada and places like Australia. But you don't know many things about those countries. Just hear everything. See somebody just posting that the what's it called on Facebook, and then in Canada now, very good, and all of that. And then you went to apply. Now you didn't know that. Now, a place like Canada is a very big country, but very small number of people. So what are they trying to do? Now, the small number of people is making the effect of the cold to be much on them. So it's not as if they like you. They want you to come and fill the space so that the effects of what they are feeling will not be so much. So they are bringing people in. Normally before, now places like Canada and Australia, they were countries where if you commit offense in the UK, maybe you or your family, now they send you there to go and die. Yes, because of the cold. If you go to Canada, most of the people there, they are from UK. They are forefathers. They are from UK. They are not we have the Aboriginal in those places. They are not actually the owners of the land. The Aboriginal in Canada, they are not white. And the Eskimos, if you find the stories around those people, so you find out that those places are meant for prisoners, people that have been condemned in the UK. They are criminals. They have punished them and they have banned them. So the expectation is that they will go there and go and die. But some of them go there because of the cold. Some of them died actually because the cold is, you be getting like minus 20, yes, minus 30, minus 45. You see the kind of jacket they wear is not the kind of you wear in UK or in Europe. It's like, all this masquerade. You'll be like a masquerade. Right? So what are they looking for? They want to beat the effect of the climate change. And it's becoming more intense now. Places like the Europe, where even Switzerland, where there are less cold before, now you are getting minus 20, minus 10. Yes. You freeze. Now your freezer, what is what's the temperature of your freezer? Eh? You don't know? Eh? Minus what? No. Freezer. Okay, some of your freezer are minus 4. I mean, your freezer is not up to that too. It's 0. It's 0. Your freezer is 0. If you enter your freezer, you will crash. Not to talk of when you are entering minus 45. Your freezer is not up to minus 45. It's 0. Freezing. What's the freezing point? That's the freezing point. It's 0. So we are not talking about minus. So that's an extreme case. So now we have climate risk management. So we have the climate scenarios. These are climate scenarios. You have the heat map. This heat map is talking about certain times in the year where you have. So some of these green stuff, they are talking about the period or the timing where you are having very strong influence. And then the intervention technologies and the simulation models on water, on health, on agriculture, and all that. Now, where now climate risk management, where should we start in public health? So we need to define the problem as your own case may be, maybe in terms of what you want to do. You define the framework in time and space. You identify partnership needed for solution. Identify the source of data. Identify and create tools and methodologies. Create and manage and share data. Identify risk management opportunities. Implement risk management activities. Evaluate impact on health outcomes. Now, the dynamic process for building a community of practice. So these are things that when you are thinking about the influence of climate change on public health, these are questions to begin to ponder on. What is the way forward going on from here? Now, it's not moving on. Okay. Now, risk management. How do we manage the situation? Risk is a function of hazard and what? Vulnerability. Now, there are hazards like disease, like communal crisis, and a lot of them. So you need to identify the issue and its context. Now, identifying the issue. What is the challenge? Which area are we being affected? Now, a lot of time people are using, like, take for instance, some of they are bringing out, they are deploying chemo prevention, seasonal chemo prevention in certain states in Nigeria now. Now, because it's seasonal, now if the health workers or the health providers, if they don't understand the timing of deployment, now the seasonal chemo prevention is not going to work. Because if you are giving it at the wrong time, and then the results, the output or the result you are getting, because seasonal chemo prevention is given to children under 5, because children are the most vulnerable group when it comes to malaria. So they have arranged this kind of prevention intervention for them, so that they can be kept, and we can reduce mortality due to malaria among children under 5. So, but the challenge is that we are still in certain states, we are still seeing increase, because most of the people that are doing this, giving this out, health providers and all that, they are giving it at the wrong timing, and this is really affecting the rate at which intervention will have had effect in such places. So now, giving an intervention also is also a function of climate. So if you give it at the wrong time, and then there is mosquito abundance, maybe before the children are already infected before you are giving. So these are things that we need to look at. Some of the things we may be presenting in the course of this training and conferences, being able to see the timing. What are, sometimes, especially on that wavelength analysis, time series analysis, we have models that shows not just the frequency of the peak. You are seeing a peak of a particular disease, but it also gives us the timing of that peak. Maybe in January, there's a peak in Benue. There's also that same peak in Kogi State. Then you know that the same kind of intervention can be deployed to that kind of location. So we have mathematical tools that can show that, given the data. So all of these things has to be put in place, because in guiding people who are doing the job in the field. Now, monitor and evaluate results. These are things to do. And all of them, the intersection around all of this: implement strategies, select a strategy, identify and analyze options, assess risks and benefits. And then this is the framework for risk management. But at the center of it all, involve interested and affected parties. Now, anything you are doing, that was why we are saying that. Now, you said you are doing cholera modeling, or you are carrying out a work, epidemiological work on cholera. But the people that are involved, they don't know. Like, take for instance the State Ministry of Health. You are working along with them. That's the kind of work that can fly and thrive. Because at the end of the day, they are seeing, even if you are using machine learning or artificial intelligence, they could see the results and they can follow you. And from there, you will begin to affect what is going on in your state. Now, research has gone beyond sitting in your room or in your office, and then you are designing stuff without the various parties involved. State Ministry of Health, starting from there, primary health care center, you are people that you are working with, that what you are doing can, at the end of the day, be feedback into their system. So, involve interested and affected parties. That's at the center of it all. Now, define the problem user needs. Okay. So, is this disease increasing or decreasing in incidence? Is that an upward trend or a downward trend? Does its incidence correlate with some suspected cause or a defined population subgroup? Does incidence vary during the year or season? Now, you are seeing the incidence of Lassa fever in a particular place, but have you compared it with certain seasons or certain, maybe rainfall or temperature, to see any correlation between that incidence and the climatic variability? Maybe the seasonality you are seeing is being driven by temperature or by precipitation or by humidity. So, have things changed since control measures were introduced? Did you see a decline in the disease progression? There's a decline because we have introduced, maybe after a certain time, we introduce what's it called? Control. And then we begin to see, there's no pen here. We begin to see a decline, a downward decline. So, it's an association between climate and dengue or malaria. Is there any association between climate and cholera? Is there any association between climate and CSM, cerebrospinal meningitis? Is there any association between climate and other diseases, measles? Because the climatic factors is not what you can downplay. At what temporal and space scale? Now, when we say temporal, we mean time. When we say space, we mean location. Now, what is the attributable climate risk for dengue? Is it temperature? Is it precipitation? Is it humidity? We need to find out. Is rainfall a good predictor of dengue outbreaks? Although dengue is not a major threat in Nigeria, but there are some places in Nigeria that have dengue. Yes. Now, what other factors are important in the dengue transmission? What is the perception of climate change and dengue or cholera or other diseases in the population? The perception. Now we have discussed this. Thank you very much.